Hello, my name is Nitin. In one of my previous videos, I evaluated DAISY module WPT 2.0, which scans 8 times faster and handles more complex signals than version 1. Module WPT, which is based on Spiag's MACPI technology, has evolved and adapted to changing technology and regulatory requirements thanks to regular updates from Spiag. Today, I want to test version 2.8. This new version includes important enhancements for testing the latest fast chargers that utilize frequency or amplitude shift keying FSK or ASK to coordinate power transfer and optimize charging efficiency. The test setup here has the device under test, which is a commercial 15-watt charger. I've already placed the phone on top of the charger. The phone has run out of battery. The reference sensor is positioned next to the charger and the probe has been moved to the phone's surface. I now switch on power to the charger and check charger transmission in the frequency domain. This charger transmits at a peak frequency of 360 kHz. So I narrow down the peak frequency search range to 360 kHz. Next, I start the time sweep that is available here in the preview part. The visualization shows the peak frequency and magnetic field amplitude over time. I accelerate the video. After approximately 4 minutes, the phone boots up. This causes a short disruption of the charging process. Now, the charger adjusts the field to a higher value for optimized charging. The plot is live. I can use cursor reading or even add annotations to investigate the field variation. To save time, I stop the sweep and show the plot for a 2-hour time sweep I made earlier. It is helpful to identify the maximum exposure period, which in this case lasted for approximately 8 minutes and occurred within the first 15 minutes. The time sweep can also be used to assess the field change during the removal of the load. Let's proceed with the volume scan. I create a project and use the phone's top center as the DUT teaching location. The worst case charging time of this charger most likely is not long enough to complete a volume scan. This required special user adjustment in the past. Now, the new reference scaling automatically adjusts for any variations in charger emissions at each measurement point using the reference sensor's relative field. Hence, I should get the correct worst case exposure at the end. I start the volume scan and accelerate the video. The scan finished after 15 minutes. I load the result file in the post-processing part. First, I confirm that the auto extend mode and the reference scaling feature have both been enabled in the scan info tab. I do a sanity check based on the measured field distribution. The hotspot of the magnetic field corresponds to the area where the coils are not perfectly shielded. Now, I navigate to the reference scaling tab. I can also see the scaling factors derived as well as the peak frequencies recorded. Here, I can check the magnetic field variation at the DUT teaching location through the volume scan. The field stayed at the highest level only for a part of the scanning period and it dropped in the end of the scan. Next, I start an evaluation at 0 mm distance. The computation takes half a minute. Let's take a look at the results. The peak induced electric field is 0.235 volt per meter, which corresponds to the maximum exposure during the entire scanning period. In summary, DAISY 8 Module WPT version 2.8 includes the essential new feature to automatically test advanced fast chargers that utilize FSK or ASK to coordinate power transfer between transmitter and receiver. Thanks for watching this video.